Okay, so question number 3 says to draw the Lewis structures for A, B, C. So let's do the first compound. We first need to find the total number of valence electrons. So the silicon atom has 4 valence electrons. And fluorine contains 7. And since there are 4 fluorine atoms, we just multiply this by 4. And if we were to add these all up, we'd get a total of 32 valence electrons. So now let's just write our central atom. I can move over a bit. That is single bonded to our 4 fluorine atoms. And then I'm also going to draw in all of the lone pairs. Okay, so if we count out all the electrons I've drawn so far, we have a total of 32, and everything is satisfied in terms of having a full octet. So I know we have the correct Lewis structure. So now let's go on to our next compound. If we were to calculate the total valence electrons, selenium, I believe, contains 6 valence electrons. And chlorine contains 7. And we multiply this by 2 since there are 2 chlorine atoms. So 14 plus 6, we have 20 valence electrons. And selenium will be our central atom, and it'll just be single bonded to both of the chlorines. And each of the chlorines will have their lone pairs. So if we count out the electrons I have so far, we only have 16. So for the remaining 4, I'm just going to add them as lone pairs on the selenium. And now everything should have a full octet. And we have a neutral molecule and the right number of valence electrons. And now we need to do the last compound. And they gave us a hint that carbon would be the central atom, so that's good. So now let's calculate the total number of valence electrons. Carbon has 4, oxygen has 6, and fluorine has 7. And there are 2 fluorine atoms, so we just multiply this by 2. So if we add these all up, we get a total of 24 valence electrons. And now let's try to draw the structure. We have carbon as our central atom, and it's bonded to 2 fluorines and 1 oxygen. So let's see what happens if I draw in all of my lone pairs. Okay, so if we look at this structure, we'll notice that not only does oxygen contain a negative charge, but also our carbon doesn't have a full octet yet. So if I bring these electrons down to form a double bond, then we get the following structure, where carbon has a full octet and oxygen would then be neutral. And if we double check and counted out how many electrons are in the structure, then we would have our 24 electrons. So this is the correct Lewis structure for the COF2 molecule. Okay, so the junior tutor said for part A, first determine the total number of valence electrons, so they got 32. They have a plausible skeletal structure and wrote out all of the lone pairs and got the same Lewis structure I did, so that's correct. For the next molecule, 20 valence electrons, okay, so that's correct. And then for the last one, 24, and they have the double bonded oxygen. So this solution is correct.